Hello, everyone, and welcome to the second episode of the Control Loop, our podcast on building agent economy. I'm Daria, co-founder of EternaX, and I'm joined as always by my co-founder Parthh. And today we have a special guest. We are joined by Dr. Chen Feng, our chief scientific advisor and one of the world's experts in trusted compute, multi-agent systems, security of consensus, and all things related. We will be diving into verifiable cognition, a foundational breakthrough for autonomous agents on chain. So, who is Dr. Chen Feng?
So first of all, Jen, I'm really glad that you joined the team, and you have worked across some of the hardest technical challenges in cryptography, distributed systems, and AI trust layers. So can you just walk us through how your journey has evolved so far? What has brought you to the stage that you are in today?
Oh, sure, yeah, pass. My research journey has had three interesting chapters. My chapter number one is about blockchain security analysis. And basically, I think I started this line of research in early 2007. At that time, I was focusing on one thing, only one thing, how to prove that a particular consensus algorithm is secure. And I thought, right, it was mostly academic, like no applications, just for fun, right, to play some math, to understand more. Then I had my second chapter, which is from theory to product. Basically, everything changed when Dapper Labs approached me, telling me that their crypto kitties was so popular that they had jammed the entire Ethereum. So they decided that they needed to build a new blockchain, and my group built a prototype to help them, and which later on converted to an important component of their flow blockchain. So this is an interesting here because like I could say like how my research can be turned into a live network. After that, I started to have more projects, in particular autonomous. Then this brings me to my third chapter. It's like bridging AI and blockchain. You know what? Like I know AI for a long time when I was a student at the University of Toronto. As a particular example, at that time, I shared a lab with Jimmy Barr. For those who are unfamiliar with Jimmy Barr, he co-invented and this important training algorithm, and he co-founded XAI. But now like, it's a big thing. So like I was like sitting beside him, and I had like many discussions and with like different people in machine learning. So I was at the University of Toronto in the right time. So now it's clear, right, with AI background, with my deep expertise in blockchain. At this time, what excites me most is how to bridge these two, making the best part. And this is the very reason I decided to join external arts.
Yeah, I mean, and we're certainly grateful for all the baggage of experience and knowledge you are bringing to the team. So let's get into something a little more technical. What do you currently see as like fundamental limitations in the infrastructure today for bridging AI and Web3 and interaction of AI and blockchain systems? Why would we need like new technologies and new stack for that?
Yeah, this is a very good question. So maybe I can start from the limitations of like current large language model based agents. After we understand their limitations, what and we will say the current infrastructure is not ready yet. Limitation number one is about persistent low memory. Currently, I think agents tend to forget things, right, for several reasons. One of them is about the lack of low memory. The second is about verifiable proof. So basically, after agents act, there is no proof that they are doing the right thing. And this is not good, right, for certain applications. The third limitation is about independence. And basically, today's agents rely heavily on this centralized APIs, which implies that you need to trust some centralized party completely. So, right, and these three limitations basically give us some hint on what kind of AI infrastructure we should build, right? Like how kind of blockchain can help solve their like issues. So in one sentence, like agents should be able to identify, verify, and collaborate with each other in a trustless way. So, right, this is missing for AI infrastructure, and this is the gap that our project is trying to address. I believe, and we are doing a very good work, and we will like say later.
Sure, sure, Dr. Chen. I think, you briefly touched upon verifiable compute here, and when when I read through your papers, you have done extensive work on TEEs, which is, directly under the, regime of verifiable compute. So, would you shed some light on how TE environments is foundational for verifiable cognition?
Yeah. So let me quickly explain TEs a little bit. So basically, they run code inside a sealed box. And why? Right, for like beginners, and basically can view it right as like a secure log. Right, if you run code inside this log, there are two guarantees. Number one, like exact code is running, it hasn't been like modified or tampered. So this is guarantee number one. Guarantee number two, and the data, right, like related to the code is like a secure, private, and no one modifies. So these are the two guarantees TEs can provide. With this in mind, we can say that this allows agents to keep their data completely private and right, even better. And after that, they will like publish some audited thread, and this is called attestation in the TE literature. So what you can like everyone else can verify and they can double check. Good. Why is this important? Because it is so critical for certain agents, such as this financial agents, right, to like allocate their capital, like validate oracles and other things. We need to verify the code is unmodified and some like sensitive data is completely private. Even better, you know what? According to the latest research, the overhead of running is rather low, like 5% overhead, even lower, right? Kind of even on the state of the art GPUs such as H100. So, right, this is amazing because there are some alternative techniques such as ZK, FHE, no surprise, their overhead is large. So that's why like we kind of bet on TEs in the near term. Now every technology has its limitations. So does TE. Basically, they are suffering from physical attacks, and that's why I wrote several papers with my collaborators, but showing that, oh, in the blockchain context, how can we overcome the limitations of TEs so that we can do even better, more secure? One hint is we can combine different techniques such as MPC with TEs, right, to take the best of both worlds. If you are interested in this line, and you can find my research papers on archive.
Yeah, we will link them in our episode. And let's dive in a little deeper on that. So we've talked about a lot of like different texts so far and the agent limitations. But what does all of that have to do with how we implement the vision of agent economy? Like why is the cognition layer that me and you designed so different?
Yeah, very good. So when it comes to the population now, I feel that we can like roughly divide it into two types. Right, one is the neural nodes, and basically, and they can run model inference securely using the technique I just mentioned, a combination of MPC and TE. The second is our real strength. I call it context nodes. But basically, they can store and retrieve this long-term encrypted memory. Because I mentioned, right, like long-term memory is the limitation. And now, if we can provide this long-term encrypted memory, like fast retrieval, like verifiable, all the data there should be correct, right? So like this. And now you can imagine if we have this like two types of nodes running as our cognition layer, and then like no memory can be tampered, and you cannot like change and encode. So this increase our confidence and the security level. So to the point that we can even call it accountable cognition, because every decision, right, no matter big or small, made by an agent can be independently verified, which means that humans can have a peace of mind. Of course, it's not easy, right? And there are many like challenges out there. So that's why what we need to build, we need to improve. Still, I would say roadmap ahead of time.
This is you being humble,
Yeah.
Dr. Chen. You really have made these things easy for us, and with you in the team, cognition layer is seems pretty easy.
Well, that's certainly a lot of stuff that we're going to have to work on and still a lot of topics to discuss. So, in our very next episode, we're still going to have Dr. Chen with us, and you're going to see him often. And we are going to be discussing multi-agent systems and coordinations. So, thank you, Chen. Thank you, Parth, and everybody else. See you next time.
Yeah, thank
Thank
you,
you, everyone.
Daria. Thank you, Paz. See you next time.